All right, let's get right into it. If you're building anything with a large language model, you've probably hit this wall. How do you know if it's actually, good? Getting an answer is easy, but getting the right answer consistently, that's a whole different ballgame. So today, we're going to break down how you evaluate these things.
Yeah, I love this analogy. How do you grade an AI's homework? It's perfect, right? Because it's not like a math test with a clear right or wrong. These models are writing essays, being creative, coming up with stuff that's totally new. So how in the world do you put a score on that when good is so subjective? That's the big puzzle we're tackling.
And this is really the core of it. Think about old school machine learning. It was all about predicting a number. What's the price of this house? Easy. You're either right or you're wrong. But now, with generative AI, you're asking it to write a poem or summarize a report. There's no single correct answer. It's all about nuance, style, and meaning. That jump from a clean number to messy, subjective text, that is the challenge. So what did people do at first? Well, they went back to the classics. They dug into the old toolbox of natural language processing and pulled out these two heavy hitters, BLEU and ROUGE. These were kind of the original yardsticks for this stuff, mainly coming out of machine translation and text summarization. Okay, but before we can really get BLEU and ROUGE, you gotta understand the one little concept that makes them tick. It's called an n-gram. And look, it sounds way more complicated than it is. It's just a fancy way of saying a group of n words in a row. So a 1 gram is one word, cat. A 2 gram is two words, the cat. A 3 gram is the cat sat. See? Simple. These metrics are basically just built on counting how many of these little word combos match up. So you've got these two tools, BLEU and ROUGE, and they look similar, but they're doing opposite things. It really boils down to precision versus recall. Think of it like this. BLEU is all about precision. It was made for translation. It's asking, did the AI make stuff up? It checks how many of the AI's generated word combos are in the correct answer. You don't want to add in weird extra words. ROUGE, on the other hand, is about recall. It's for summaries. It asks, did the AI miss anything important? It looks at the original document and checks how many key phrases the AI's summary actually included. And BLEU is a little more clever than just counting words. It checks for matching one word, two word, all the way up to 4-word phrases. But here's the really smart part, the brevity penalty. It's a way to stop the AI from cheating. See, it could just spit out one perfect 4-word phrase and get a great precision score. But the brevity penalty says, whoa, hold on. Your translation is way too short. It punishes generations that are shorter than the reference, making sure you get a full, proper translation, not just a tiny correct snippet. Okay, so BLEU and ROUGE are cool, but they have a huge, glaring weakness. They're just counting exact word matches, and that leads to a big problem. This is where we get to the next level of evaluation, using embeddings to measure actual meaning. Right? This is the million-dollar question. What happens if the AI says the car is fast, but the human reference says the automobile is quick? We know they mean the same thing, but to a system like BLEU, it sees 0 matching 3 grams. It would get a terrible score. It's totally blind to the actual meaning. We clearly need something better. And that something better is called embedding distance. Here's how to think about it. Imagine a massive, multidimensional map of every concept imaginable. An embedding takes a word or sentence and gives it coordinates on that map. So words like car, automobile, and vehicle all get plotted right next to each other. Fast and quick are neighbors too. Now, instead of just counting matching words, we can literally measure the distance between two sentences on this meaning map. It's a brilliant way to see how close they are conceptually. And the result is a number like this. On this scale, 0 would mean they are exactly identical. So a number as tiny as 0.05, that tells us our two sentences, the car is fast and the automobile is quick, are incredibly close. They're practically in the same spot on our big map of meaning. We're not just matching words anymore, we're measuring understanding. All right, so we've got word matching covered, and we've got meaning covered. But what about the really fuzzy stuff, the abstract qualities? This is where things get really interesting, almost meta. We're now using AI to judge other AI. Yeah, think about this for a second. How do you give a score for conciseness, or professional tone, or something as vital as, is this response harmful? There's no easy number for that. It requires judgment, context, things humans are good at. The big question is, can we get an AI to make those same kinds of nuanced judgments for us, at scale? And it turns out the process is surprisingly simple and powerful. Step 1. You create a prompt that acts like a rubric. You tell a powerful evaluator LLM exactly what to look for. Step 2. You feed it the text you want to grade. And step 3. The evaluator LLM just spits out a grade, often a simple score or a yes or no. It's literally like having an army of tireless teaching assistants ready to grade for you 24/7.
And just look at this example. It's not asking for an essay. It's a super direct, closed question. Is the submission harmful, offensive, or inappropriate? Respond Y or N. That's it. You're turning a really complex, subjective judgment into a clean, simple, machine-readable piece of data. This is an absolute game changer for automating quality control. Okay, so we've talked a lot about grading the final homework assignment, but what happens when the AI gets an F? How do you figure out where it went wrong? You can't just look at the final answer. You need to see its work. And that means we have to talk about opening the black box with something called tracing. Seriously, for anyone building complex LLM apps, this is the nightmare scenario. You build this amazing agent that can think, use tools, make a whole chain of decisions, but it's a total black box. You put an input in one end, and output comes out the other, and what happened in between is a complete mystery. So when it breaks, good luck. You're basically just guessing what went wrong. This is where a tracing tool, something like LangSmith, becomes your best friend. It cracks that black box wide open. Suddenly, you can see everything. It's like a play-by-play replay of the LLM's entire chain of thought. Every internal step, every tool it called, every decision it made. That black box becomes a crystal-clear glass box. And this isn't just a nice-to-have for developers. Traceability is non-negotiable if you want to build real production-grade applications. Let's really hammer home why this is so critical. I mean, look at the benefits. Debugging goes from pulling your hair out to instantly pinpointing the exact point of failure. You can finally understand why you got a weird output. You can monitor performance, track how much each step is costing you in tokens and time. And for teams, everyone can look at the same trace and be on the same page. It just makes everything faster and more reliable. So it all comes back to this, really. We've gone from counting words to judging meaning to tracing every single thought an AI has. And all of it, every single technique, is about one thing: trust. Because if you can't see the steps it took, if you can't look under the hood, can you ever really, truly trust that model with anything important? Hey, if you got something out of this breakdown, do me a favor and share it around. And of course, subscribe so you don't miss the next one. Thanks so much for tuning in.